Differentiation Techniques Part 2. This lesson is Part 2 in this Differentiation Techniques series. We'll cover 6 more problems in Part 2. These are the 8 methods of differentiation we'll be using in this 4-part series. Again, from the first video, here's a list of different ways of saying differentiate. And here's a list of why we might get an idea that we should or need to differentiate. And again, of the differentiation techniques, the power rule reigns preeminent as the technique used most frequently. In Part 1, we've covered problems 1 through 6. In Part 2, we'll cover problems numbered 7 through 12. Problem 7. The slope of the line normal to the graph of y equals 2 ln secant x at x equals pi over 4 is, and we're given our answer choices A through E. Note the underlining of the word normal. The test writer is trying to be sure that we don't forget it, so he's really doing us a favor. And the slope of the normal line we'll call m sub n. What is a normal line? If we have a curve like this one, and we have a tangent line at a point along the curve like this one, the normal line is the line perpendicular or at a right angle to the tangent line. So to find the slope of a normal line, we must first find the slope of the tangent line, and to find the slope of the tangent line, we need to differentiate the function and evaluate the slope at an input value of pi over 4. Here we are taking the derivative of a natural log and in conjunction with the secant differentiation. And the derivative of ln u is the derivative of u, or u prime, divided by u. So we'll need to get the derivative of secant x. And for that we'll bring back our tan x, secant x, like we did in problem 4 in part 1. And to get the derivative of secant x, we'll cover one of the secant x's like I do here with my thumb. So the derivative of secant x, or secant x prime, is tan x secant x. So to differentiate, we have 2 times tan x secant x over secant x. And secant x over secant x canceled equal 1. So that leaves us with y prime of x equals 2 times the tangent of x. Now we can look at y prime pi over 4 to replace x with pi over 4, and it's equal to 2 times the tangent of pi over 4. And getting out the unit circle, which you probably don't need, but we'll just look at it, that pi over 4, that sine x and cosine x are the same. Cosine x is square root of 2 over 2, and sine x is also square root of 2 over 2. And so the tangent of pi over 4 is 1. So we have y prime of pi over 4 equals 2 times 1, or 2. And if we're a bit careless, we'll circle answer D and be done with it and get it wrong. And why will we get it wrong? Because we're looking for the slope of a line normal to the curve at pi over 4. But we have just found the slope of the line that is tangent so far, which we'll call m sub t. And since the slope of the tangent line is 2, the slope of the normal line is going to be the negative reciprocal of the tangent slope. So we'll say, therefore, that m sub n is going to be negative 1/2. So we box in our slope of the line that is normal and circle the correct answer, B. Problem 8. At what value of x does the graph of y equals 1 over x squared minus 1 over x cubed have a point of inflection? And we're given our answer choices A through E. First comes the part where we try to understand what's going on. A point of inflection is where a curve changes characteristics from concave up to concave down, or from concave down to concave up. Points of inflection, or possible points of inflection, are found where the second derivative of a function is equal to 0. This is something you have to know, or you should know at this point in your calculus career. To get prepared to differentiate, we'll rewrite the function in what I call calculus-friendly form. In calculus-friendly form, we have y equals x to the negative 2 power minus x to the negative 3 power. Why do I call this format calculus-friendly? Because from this form, it's a lot easier to use the power rule to differentiate. And differentiating once using the power rule, we have y prime equals negative 2 times x to the negative 3 power minus negative 3x to the negative 4th power. Minus negative becomes plus, so we have y prime equals negative 2x to the negative 3rd power plus 3x to the negative 4th power. Since we're looking for a point of inflection, we'll need to differentiate a second time, and differentiating a second time, we have y double prime equals 6x to the negative 4th power minus 12x to the negative 5th power. Now to find the inflection point, we need to set the value of the second derivative equal to 0. So we have 0 equals 6x to the negative 4th power minus 12x to the negative 5th power. Now to start solving for x, we can add 12x to the negative fifth power to both sides of the equation and get 12x to the negative fifth power equals 6x to the negative fourth power. Then we can divide both sides of the equation by 6 and we get 2x to the negative fifth power equals x to the negative fourth power. And at this point you might be tempted to say that our answer is 0 because when x is 0 it seems to make both sides of the equation equal to 0. But x cannot be 0 because we must remember that x to the negative fourth power on the right side means 1 over x to the fourth power, which means that the equation is not defined where x equals 0. So 0 is not the value of x that has a point of inflection. An input of 0 is in fact an exclusion to the domain of the original function, let alone the second derivative. We can go about simplifying by multiplying both sides of the equation by x to the fourth power. So we have 2x to the negative fifth power times x to the fourth power equals x to the negative fourth power times x to the fourth power. And this simplifies to the equation to 2 times x to the negative 1 power equals 1. And we can rewrite the x to the negative 1 power as x in the denominator, so we have 2 over x equals 1. At this point it should be apparent that the value of x that makes the equation a true statement is when x equals 2. So we box in our answer and circle our correct answer choice, C. Problem 9. If x equals quantity x squared minus 2x minus 1 to the 2/3 power, then f prime of 0 equals, and we have again 5 multiple choice answers A through E. In this instance, because we have an expression raised to a power, the power of 2/3, we have a power rule application. Yet, because there is an entire function and not just x raised to the power of 2/3, we will need to apply the chain rule in conjunction with the power rule. And differentiating using the power rule and the chain rule, we have f prime of x equals 2/3 quantity x squared minus 2x minus 1 to the negative 1/3 power times quantity 2x minus 2, which is the derivative of x squared minus 2x minus 1. In simplifying, we have f prime of x equals 2 times quantity 2x minus 2 over 3 times the cube root of quantity x squared minus 2x minus 1. Next, substituting in 0 for x, we have f prime of 0 equals 2 times negative 2 over 3 times the cube root of negative 1. Then further simplifying, we have f prime of 0 equals negative 4 over negative 3, which simplifies to 4 over 3 or 4/3. We have our answer, which we box in as correct, and circle our correct answer for. Problem 10. The function f given by f of x equals x cubed plus 12x minus 24 is, and here are the 5 potential answers A through E. We can tell where a function is increasing or decreasing by whether the derivative of the function is positive or negative. Where f prime of x is positive, the function is increasing, and where f prime of x is negative, the function will be decreasing. So let's differentiate our function. We get f prime of x equals 3x squared plus 12. Now to evaluate, where is the value of this function going to be positive or negative? To help answer this question, we'll look at a sketch of this function, and this is what that sketch looks like. The y-intercept and function minimum is at 12, so the value of the derivative function is always positive for any and all real numbers. Therefore we know that the function f is increasing for all values of x. So our correct answer is C, increasing for all x, which we circle as correct. Problem 11. If f of x equals e to the 3 ln x squared, then f prime of x equals, and we have our 5 multiple choice answers A through E. For this problem, I'll come right out and say that this problem is really a whole lot easier than it may look at first. That is, if you know the rules of logarithms and exponents well, and the relationship between the natural logarithm of x and e to the power of x. Here the function f of x is rewritten below. And using the multiplication rule of logarithms, we can take the 3 in front of the ln x squared and multiply that 3 by 2 to give us f of x equals e to the power of ln x to the 6th power. The e to the power of natural log cancel each other, so we're left with f of x equals x to the 6th power. And using the power rule, we get f prime of x equals 6x to the 5th power, which we box in as correct and circle E as our correct answer. Problem 12. If f double prime of x equals 2x minus cosine x, which of the following could be f of x? And we have our 5 answer choices, A through E. This problem is different. Instead of asking for differentiation, in this case double differentiation because of the double prime, we are being asked to work backwards from being double differentiated to the original function that was differentiated. This working backwards from differentiating is the main concept of next semester and will be called integration. But instead of going ahead with integration, we will take the answer choices and double differentiate from these answer choices to see which one gives us f double prime of x equals 2x minus cosine x. Here's answer choice A. F of x equals x cubed over 3 plus cosine x minus x plus 1. In differentiating, we'll use the power rule on these 3 terms, the x cubed over 3, the minus x, and the plus 1. And for the cosine x term, that will be a trigonometric differentiation. We get f prime of x equals 3x squared over 3 minus sine x minus 1. What happened to differentiating the 1? Well, that became 0. Next, 3 over 3 cancel to equal 1. And we're left with f prime of x equals x squared minus sine x minus 1. And then differentiating the second time, we get f double prime of x equals 2x minus cosine x. And we should see that this double differentiation of answer A gives us what we started with in our problem. So we box in our answer and circle the correct answer choice, answer A. I like this problem in that it introduces the concept of integration. This concludes the 6 problems, 7 through 12 in Part 2. In review of our 8 techniques listed here, we have used all these techniques in Part 2 except the quotient rule and implicit differentiation. This has been Differentiation Techniques, Part 2. Thanks for viewing.